Welcome to Techonica, the Java tutorial channel. Today, we will learn about the Java virtual machine. As we discussed in the earlier session, we will discuss how Java is making the magic of platform independence. So let's get started. Java virtual machine. This is a specification that provides a runtime environment in which Java bytecode can be executed. So, what is this Java bytecode? Actually, Java attains platform independence by bytecode. Whenever we compile a Java program, it compiles it to a Java bytecode format. This bytecode can be understood by a Java virtual machine. Even though we are telling Java is a platform independent language, JVM, JRE, JDK, that is Java Virtual Machine or Java Development Kit or Java Runtime Environment, they are not platform independent. They are actually platform dependent. So once we compile a Java program, it gets compiled to a Java bytecode. This bytecode is understood by a Java virtual machine. So if I'm using a Windows system, I'll be installing a Java virtual machine of Windows. If I'm using a Linux system, I'm using the Java virtual machine of Linux. So what will happen is that if I'm going to run the Java program, the Java program has bytecode which can be understood by the Java virtual machine. So when it runs on a Windows machine, the JVM understands the bytecode and then in turn converts the bytecode to the CPU understandable instructions of the Windows OS. When it executes on the Linux system, the same thing happens. The bytecode gets analyzed by the JVM and it will convert it to a CPU understandable instructions which can be executed in the Linux platform. So today we will see what constitutes or what are the basic constituents of a Java virtual machine. In short, what Java Virtual Machine does is that it loads the code, it verifies the code, then it executes the code and finally provides a runtime environment to run the code. So if you're not a developer, then you'll be using a Java runtime environment to run the Java program. The Java runtime environment consists of a Java virtual machine inside that. So this Java virtual machine will be taking care of running this Java program of yours. It provides us memory area, class file formats, register sets, garbage collection, and even the fatal error reporting part is done by the Java virtual machine. So we will have a look on the basic architecture of Java virtual machine. Here you can see this is a schematic diagram of Java virtual machine architecture. So it contains a class loader, then the JVM memory area, then the execution engine, the native method interface and the native method libraries. We'll be going through a brief introduction of what these things are and what are their functions. Okay, first we will see what is a class loader. If you are new to Java program, then the terms that we are going through in this session might be a little difficult for you to understand, but leave it aside. Just hear me out. After you progress in this Java tutorial, you can come back to this video and watch it once again. At that time you'll get a high level overview of what exactly this JVM is trying to do with our Java classes and all. So when we are writing a Java program, we'll be writing classes. So since Java is object oriented and unlike the C language, if you see, I can write a C program completely structural without any object oriented concept in it. But Java, if you write in however way you want, it will have some object oriented concepts along with that, because we'll be writing our functions inside one class file. So anyway, when we are writing a Java program, at least one class file will be there for us. So this class files, actually we'll be writing programs in .java file. Once we compile this program, this converts to .class file. So these classes we need to load to the JVM. That is what the class loader does. It is used to load the class files. There are three class loaders. The system, we will just write it down. First one we will discussing is the class loader. So the class loader is basically for three types. That is the system class loader. First, the system class loader. So what is the system class loader? It is simply the classes that we create. We will be writing several classes for the business functionality that we need to implement. Those classes will be loaded to the JVM using the system class loader. Loads all classes from the class path. While we are writing the Java program, we will be adding our programs to a path. We will be giving the compiler instruction where we are going to write all the .java files. These Java files will be converted to class files and added to the class path. From the class path, the system class loader will take these classes and give to the JVM runtime environment. The next one is the extension class loader. Java is actually a program where we can get help from n number of locations. There are so many frameworks available. There are so many packages, so many custom jar files available for us to make our tasks easy. So if I'm going to do a project, I won't be using my own Java files, my own things in my project. I'll be importing some custom help jar files available in the market. If you're using a framework like Spring or Hibernate, they'll have an enormous number of classes, so I can use those classes and add it to my program. So those are in libraries or in extension folders. These libraries will contain some jar files. Jar is Java archive, which is having a set of classes, compiled Java program. I can use those classes and add it to my class path, and then I can use these classes inside my Java program. So while I'm loading this to my program, when I'm loading to this JVM, I need these extension classes also to be loaded to the JVM. So the extension class loader loads all the classes from the extension directory, that is from folders like lib, lib, ext, etc. The next thing is the Bootstrap Classloader. The Bootstrap Classloader loads all the Java related classes. Java related classes like the core Java will be containing several classes to execute this program, like the rt.jar, those kind of jar files. It loads all the core Java files. That's it. So once these three class loaders finish their activity, all the necessary classes that we need to run the program will be available in the JVM. So the order in which it executes is that when we need a class, means we are declaring our in program we need to find a class, it will first search that in the system class loader. If it is not there, then it will go and check in the extension class loader. If it is not there, then it will get the class using the Bootstrap class loader. Even at this stage also it's JVM is not able to find the class, then we will get an exception called the class not found exception. So I'll just write it down. If not able to find the class, then we will get the class not found exception. Class not found. Okay. So that's it for this class loader. Next we will move on to the class area. You can see it in architecture. JVM memory is there, so we will just give a brief overview of what are the different types of memory management available in the JVM. The first one is a method or class area. So I'll write that one, class or method area. It stores the per class structure, means the runtime, constant pools, field and method data, the code for methods, all these things will be there in this class area. So in short, what it will contain is, it is a storage for the compiled Java code. Storage area for the compiled Java code. Next is a important memory classification in the JVM, that is the heap. So you can see it in JVM memory. Heap is there. So what is heap? Heap is the runtime data area where objects are allocated. So what is meant by that? When we are running a Java program, we'll be creating different objects of these classes. When and while we are creating these objects, it will be allocated to the heap. Heap is created at the JVM startup, means when we are starting up the JVM Java virtual machine, heap memory is created and it can increase or decrease the size as the app runs. Also, so what is heap? Heap is runtime. Heap is the runtime data area where the objects are allocated. Now sometimes this heap is divided into two areas or generations. That we can give is the young generation, that is nursery, and an old generation, that is old space. So what is this nursery and old space? Nursery is reserved for the allocation of new objects. When we create a new object, that will be the memory of that will be allocated in the nursery. And when the nursery is full, garbage is collected by a special young collection. See, what is garbage collection means? Java actually automatically does clearing of memory for us. So when we create an object and we use it, and when that object is no longer required or when it is no longer live, Java will automatically clear that from memory. That is called garbage collection. So when the nursery memory is full, what it will do is it will check whether the scope of some objects are gone or not. If the objects are gone, then what it will do is it will remove that from memory. If after some time, if some objects live long enough in the nursery, then they are promoted to the old space. So when the old space is full, garbage is collected there by an old collection. So when nursery is full, we use the young collection. Collection means the garbage collection we are referring here. Garbage collection is the removal of objects which are not in scope. This old memory is cleared using an old collection. Now one question arises, why we are partitioning it to this nursery and old spaces, this two distinction. The reason behind nursery is that most objects in Java program will be short-lived, and the young collection is designed to be swift at finding newly allocated objects that are still alive and moving them away from the nursery. So when an object is an object is of short life, this nursery young collection will easily remove those objects from the memory and is more efficient. The next is the stack, the JVM language stacks. So what is a stack memory actually? In Java, stack stores frames of data. it holds variables and partial results. When you are executing a function, there will be partial results in the being to be calculated. Those partial results or variables you are creating, those will be saved in stack. And it plays a part in the method invocation and return. While you invoking a method, it will require this partial results and variables, memory and all. Those all will be allocated in the stack. And one more thing we need to understand is that Java has threads actually. Thread is like a different process to be executed at different times. So each thread, whenever a Java thread is created, it has its own private JVM stack created at the same time as a thread. So a new frame is created each time a method is invoked, and a frame is destroyed when the method invocation completes. So it basically holds what partial results and variables. And also one more point we need to write is it stores frames, and also each thread has its own private JVM stack. So that's it. That is stack memory for us. Next important thing is the program counter register. If you are familiar with any assembly level language or assembly processor, we will be using you'll be knowing what is a program counter. Program counter contains the address of Java machine instruction currently being executed. That means we will be giving instructions one by one to the CPU to do what and what next. So this program counter register keeps tracks on what is being executed currently. That it contains the address. It contains the address of what? Address of Java virtual machine instruction that is currently executed. That is currently being executed. Now what we have, the native methods stacks. It is nothing but what it will contain is, as the name suggests, native method stack. What it will contain is the native methods that are used in the application. Native methods that are used in the application. The next thing that comes in the architecture is the execution engine. Execution engine is another important thing that is present in this JVM. What execution engine does is that it provides an environment for the Java bytecode to be executed. It contains a virtual processor. It contains a virtual processor for itself for the program to be executed. Then it contains an interpreter. It also contains just-in-time compiler. That is the Java compiler that is used in the execution engine. That is just in time. So what is this just-in-time compiler? Just-in-time compiler is used to improve the performance of the compiling. It compiles parts of the bytecode that have similar functionality at the same time and reduce the time of compilation. It converts from instruction sets of JVM to CPU understandable instruction set. So what JIT just-in-time compiler does is that it converts Java bytecode to CPU instructions. It compiles it just in time to run the code. When we require to run the code, at that time only this JIT compiler will compile the code. Thus the name just in time compiler. One more thing we need to understand is that in Java there is an option that we can disable this just in time compiler, in which case the entire Java program will be interpreted. But this is not at all recommended. So this is the important things that are present in the Java virtual machine. These we have this native method interface as well as the native method libraries. So what we understood by this thing is that, see, when Java started initially at the time when C and C++ was at its peak, the one thing that Java want to offer was that platform independence, and platform independence is achieved by this JVM only. So whenever we are going to learn this Java, we should understand how JVM is going to work. An idea of how it is working will always help us in writing an efficient code. So what do you think about this session? Please let me know your views. Thank you.